Hi guys, back again with math this week. So we are moving on to one more thing that we will learn this week that's new in math. This is really to get you ready for next week. When we talk about arrays, we'll learn what those are next week, but this is partitioning rectangles. Well, what does that mean? Partitioning means I'm going to divide the rectangles. I'm going to divide the rectangles into equal parts. Now, we just learned about dividing shapes into equal parts. Did we divide some rectangles? Yes, we definitely did. So we're going to just jump back off of that and we're going to divide more rectangles into equal squares. And then we're going to make equations to figure out how many squares are inside each one of the rectangles. This gets us ready for next week arrays. So partitioning rectangles, dividing rectangles into equal squares, that's what this lesson is about. So let's look at some rectangles that have been partitioned or divided into squares in different ways. So when I look at this long rectangle, it's been divided into 4 squares. It has 1 row. So when I talk about a row, I'm talking about the side to side, right? So the ones that go across, those are your rows. There's 1 row and there's 4 squares in each row. Okay, this time they had a rectangle that was a little taller than that one. They drew a line here and here and here, and they divided it so that it has 2 rows. There's row number 1, row number 2, and there's 3 in this row, 3 in that row, and 3 plus 3 is 6 squares in all. So remember, rows go across. So this is a row, and this is a row. Okay, columns go up and down. Sometimes you'll talk about columns. I don't talk about columns a lot. I mostly talk about rows when we talk about partitioning rectangles and our arrays. But columns, just remember that's this thing. They go up and down. So these two are columns going up and down. So let me clean that up a little bit so you can see it a little bit better, and let's talk again about rows and columns just so we're clear. So when I look at this rectangle, if I could get these off of there we go. So when I look at this rectangle again, I have this row and this row. How many rows do I have? 2 rows, this one and this one. Talking about columns, remember those go up and down. So when I'm talking about columns, I have this one, 1, 2, 3, 4 columns. I have 2 rows with 4 squares in them. I have 4 columns with 2 squares in each column. Okay? All right, this is dot paper. Sometimes you'll see dot paper in your packet. So we're going to draw lines to fill this rectangle up with squares, and then we're going to see how many squares we have. So I'm going to just trace my dots and draw lines. It's not going to be perfect. And then draw my lines here in order to partition this rectangle into all of the squares. So now let's look at rows. Remember, rows are the ones that go across. Can you count how many rows there are? 1, 2, 3, 4, 5, 6. I have 6 rows. We're going to make a repeated addition sentence that will tell us how many squares there are in all. So I'm going to take the number in each row. How many are in this row? 1, 2, 3. So that's 3 for the first row, 3 for the second row, 3 for the third row. So I've done all of these so far. Now I have 3 for the fourth row, 3 for the fifth row, 3 for the sixth row. Now, there's your repeated addition sentence. That's your equation that can tell you how many squares are inside of that rectangle. Let's add them together. So I know 3 and 3 is 6, 3 and 3 is 6, right? So we're already, and then we have 3 and 3 is 6. Okay, so I have 6 plus 6 is 12, 12 plus 6. Do you have it? Count on. 18 squares in all. Let's do it again. So this time you have your dot paper. Let's draw our lines to fill our rectangle with squares. So we're going to trace our dots In order to make all those squares that are equal sizes, remember when you're partitioning your rectangles, just like with your fractions, they have to be all equal sizes. So now, let's see how many rows we have. Remember, those go across. So I have 1, 2, 3, 4 rows. Now, how many squares are in each row? Let's count. 1, 2, 3, 4, 5, 6. 6 squares in each row. So I'm going to make my repeated addition sentence now, my equation that tells how many squares in all. So in my first row, I had 6, second row, 6, third row, 6, fourth row, 6. Now let's add that together. I know 6 and 6 is 12, and I know 6 and 6 is 12, and you know 12 plus 12, no regrouping. Add your 10s, add your 1s, and you get 24. So there are 24 squares in all. If I counted each one of these individually, then I would have 24. Okay, let's write an equation to find out how many squares are in the rectangle. What does that mean? It means write your repeated addition sentence. How do you figure out your repeated addition sentence? It has everything to do with the rows. So I'm going to look at row number 1. That's the number I want to use. How many squares are in that row? 1, 2, 3, 4, 5, 6. Look at row number 2. How many squares are in that row? It's always going to be the same number because it's a repeated addition sentence. That means I'm repeating the same number. So 6 plus 6 equals 12 squares. So that would be your equation or your repeated addition sentence for this rectangle to show how many squares it has been partitioned into. All right, which statements describe the rectangle? Which things are true? There are 3 rows of 4. Do I have 3 rows? Row number 1, 2, 3. Yes. Is there 4 squares? Are there 4 squares in each row? Yes. So A is true. There are 4 rows of 3. So what this is saying is there's 4 rows in that rectangle with 3 squares in each row. Is that true? Well, how many rows did I have? 1, 2, 3. Nope. Not 4 rows. Are there 3 in each row? Nope, not 3 in each row. So B is not correct. There are 4 columns of 3. Remember what a column is? It goes up and down. So this is column number 1, 2, 3, 4. Are there 4 columns? Check. Are there 3 squares in each one of the columns? Check. So C is correct. It's true. There are 3 columns of 4. Well, let's look. Are there 3 columns? 1, 2, 3, 4. Nope, there's 4 columns, so that's wrong. So then let's look at 4. Is there 4 squares? Are there 4 squares in each column? Nope, so that's not true. So A and C are the correct answers. Let's look at this one. Kylie is filling in. Let me get my pointer so I can move things. There we go. Kylie is filling the rectangle with 15 squares. How many rows will there be? How many squares are in each row? Now we can move our squares in there. Sometimes you'll be asked to kind of visualize this, right? But if I move my squares in there and fill it up, that was my first row. Working on my second row. And now my third row. So can you make a repeated addition sentence for this, an equation to figure out the squares? You can. Remember your rows. So think about how many squares you have in each row. So in row number 1, we have 1, 2, 3, 4, 5. So the number I'm repeating is 5. In row number 2, we have 5 squares. In row number 3, we have 5 squares. And 5, 10, 15 squares in all. Okay, Chloe is using 12 squares, to make a design in the shape of a rectangle. What could her design look like? Now, there's more than one answer to this, but let's start pulling some squares out. How many do you think we should start with? You want to go with 3? All right, let's put 3 in our first row. Have we gotten to 12 yet? Nope. So let's keep on adding. Remember, we have to build a rectangle. Is that 12? Nope. So if we keep on going, this is one rectangle that she could have made. 3 plus 3 plus 3 plus 3 equals 12. Is there another one? Yeah. We could have made 4 in the row. It's row number 2. Do I have 12 yet? Nope. So keep on going. It's hard to pull these and make them look pretty. To our third row, how many squares are in each row? So I would have 4 plus 4 plus 4 equals 12. What about this? What if I said, oh, let me try 5? Well, there's a row of 5, there's a row of 5. Oh, I need another row, but if I put 5 more, then that would be 5 plus 5 plus 5, which would make 15. That's too much. Is there any way to fix this? There actually is. Guess what? If I put one here and here, then I would have 6 plus 6 equals 12. So there's 3 different ways she could make that that rectangle so that it has 12 squares in it. Okay, so if I start breaking apart this rectangle of squares, how many squares will there be? I'm going to draw lines this time to figure it out, so we're going to do a little visualization. So if I were to extend these rows and extend that one, and it looks like I would need to draw a line there, then I can see, oh, how many squares could I divide this into? Well, I have 3 for my equation plus row 2 has 3, row 3 has 3, row 4 has 3. So I have 3 and 3 is 6, 3 and 3 is 6, and 6 and 6 is 12. 12 squares. All right, Tim says it takes a total of 9 squares to make this rectangle. Do you agree? Explain. Well, what do you know about partitioning rectangles into squares? Did he partition those into squares? These kind of look like squares, but are these squares? Nope, those are rectangles. What about these? These are actually rectangles too, and they're small. Are they all the same size? So I would say, no, Tim, sorry, I don't agree with you because you did not partition that rectangle into equal parts, into equal squares. So that would not be true that it took 9 squares to make that rectangle. Okay. So that is the rest of your math, wrapping up your math for this week. We will do your seat work in your packet or on Google Slides with your partitioning rectangles and your fractions this week. Remember that partitioning rectangles will continue next week when we start to talk about something called arrays, and that'll get us to the final new part of our math for this school year. All right, let me know if you have any questions. Bye-bye.